Hi there, and welcome once again to our Smart Made session. I'm Sito Bejane, and in today's session, we are looking at a common emitter amplifier. Now, we extract our example from example 3.2 from the TVET First textbook by Macmillan and Trope Publishers. Here, we'll be looking at just some few calculations that you may need to understand so that you can tackle them in the exam center. Let us dive right into it. Example 3.2 has a circuit in figure 3.2a that has certain given information. The following values are given for the circuit in 3.2a. We have the value of VCC, which is 18 volts. We have the value of the gain, which is 210. With the collector current, IC, which is 7 milliamperes. We have the VCC, the voltage across the common emitter, which is 5 volts. And we have our frequency, which is 60 hertz. Now, at this point, they want us to assume that we are using a silicon diode that has a value of 0.7 volts as a VPE. We need to calculate the base resistance, the collector resistance, the emitter resistance, and the bypass emitter capacitor, which is CE. Now, when you encounter a question of this nature, you must at the same time be able to understand your equations. Remember, industrial electronics N5 is filled with tons and tons of formulas. Those formulas are simply extracted from the circuits. So be at a position to understand your formulas, be at a position to understand your circuitry in terms of its operation and application and functionality. Be at the position to understand all of these concepts. In that way, it's going to be easy for you to tackle these types of questions in an exam. Perfect. Now, let us calculate the base resistance. To calculate the base resistance, the first thing that we may need is to calculate our base current. Remember, the equation to calculate your base resistance, number one, the equation to calculate your base resistance, RB, would be given by VCC minus VPE divided by IB. This means that we may need to find the value of IB. We do have the value of VCC, we do have the value of VPE, we do not have the value of IB. Remember, the value of IC can be calculated by the gain multiplied by IB. We do know this equation. So we'll use that equation to find the value of IB, which is going to be that, right? So what is the value of our IC? It's 7 exponent negative 3. And the value of our beta, which is 210. This, when you punch in your calculator, as always, ensure that you reset your calculator so that it does not disadvantage you in the exam, right? Divided by 210, and we get 3, let's change it to micro, 33.333. So this is 33.333 micro amperes. Take note, I always try by all means to leave my answers in 3 decimal places. This is normally the standard decimal place that you'd want to leave your answers. This also assists that you don't get too much diverged answers from the marking memorandum in the final examination. And of course, even the question paper may stipulate to round off all final answers to 3 decimal places. But take note that when the question says round off all final answers to 3 decimal places and 33.333 microamperes is not a final answer. It means that I may choose to write it as 33.333 microamperes here, but when I have to punch it in calculations, I need to insert the whole number because that is not my final answer. It is then when I calculate RB where I could then round it off. So that is why in most cases, instead of me repunching this value, I would simply put in a value of answer. I'll just type in answer. Now, RB, we said it's VCC, VPE over IB. The value of VCC is 18. The value of VPE is given to us as 0.7. And this value here, 33.333 exponent negative 6. Let us punch that in our calculators. This is going to be 18 minus 0.7 divided by answer. When I click the button of answer, it will just insert the whole number that I have obtained here, right? So I know I will get something that is related to the answer that I want. Here, the value of RB is found to be 519 kilo ohms. Just like that. The next question, they want us to calculate the collector resistance. That is the second question. We need to calculate the collector resistance. Now, the collector resistance RC is given by VCC minus VCE minus VE over IC. What don't I have here? I do have VCC, I do have VCE, I do have IC. I've already calculated that value. No. This is a given value in the statement, but I do not have VE. But what is the value of VE? In my textbook, it is stated that the value of VE would be 1 over 10 VCC. Now, I substitute that like so, right? Punch that in my calculator and I find that the value of VE is 1.8 volts. Therefore, I go straight to my calculator now, RC. What is my VCC? 18. What is my VCE? 5. What is my VE? 1.8. What is my IC? 7 exponent negative 3. You punch that in your calculator and we find that the value of RC is 1.64 kilo ohms. It's important to always have your calculator handy. This will assist you at all times. Perfect. Now we move to the third question. They want us to calculate the emitter resistance, RE. Emitter resistance is calculated by VE over IC, where IE is equal to IC. Take note of that. IE is equal to IC. You must always remember this. More particularly when we deal with a common emitter amplifier. IE is equal to IC, 1.8 divided by 7 exponent negative 3. This is there even in your textbook. All the information are provided to you. That's how amazing this TVET first book is. So amazing. Then the last question, number 4, we need to calculate the bypass emitter capacitor, that is CE. The bypass emitter capacitor is given by 10 divided by 2 pi FRE. This formula is there in your textbook. 2 pi 60, remember that is the value of the frequency multiplied by 257.143. Now, my advice to you here, 103.156 microfarads. I want to highlight something that is very important here. You see, the value of VE, this should be VE. This should be VE. Sorry about that. That should be VE. Look at the value of VE, right? Calculate the value of VE, and then I substitute it there. The very same value of VE is also substituted there. Can you see that? Can you see that? Right. Splendid. This is RC. Now, let us look at the value of RE. The value of RE is obtained here. The value of RE is obtained here, and the same value of RE is therefore used there. Right. What am I getting into? At the same time, not forgetting the value of IB. We calculate the value of IB there. We used the value of IB there. This tells you about the importance of being cautious, the importance of using a calculator correctly, the importance of resetting your calculator, the importance of reworking your calculations at the end of the session. When I say to you, do not rush to leave the examination room. Ensure that you finish on time and rework your answers. It means that if you have if you have calculated or obtained an incorrect answer here in IB, then your RB would be incorrect. If you got an incorrect answer in VE, then your RC will be incorrect, your RE will be incorrect, your CE would be incorrect. Because all of these values, they interlink. I'm not sure if when you go to the marking center, they would use positive marking, which is normally something that is used in or applied in mathematics. But I would advise you to make sure that your calculator is perfectly functional. That's it for me for today, folks. Let us meet once again next time when we do another session of these types of calculations.